Hello students, this is Ashish Sharma. In this video, we are going to discuss about the quadratic equations. I know this sounds little boring, but wait. Have you ever imagined quadratic equation in the form of shapes, rectangles or squares? No. Can you find the quadratic equation hidden in these shapes? No. Then this video is for you. Let's decode the quadratic equation hidden in these shapes. First shape is a square of side x, and the area of this square is x square. And the another figure is a rectangle with a side 4 and x, and the area of this rectangle is 4x. And the third shape having the area 5. Can we write this algebraically? Yes, we can. Write this x square plus 4x is equal to 5. Or we can x square plus 4x minus 5 is equal to 0. Is this a quadratic equation? Yes, this is a quadratic equation and the standard form of the quadratic equation. Ax square plus bx plus c. So we can say any equation written in this form is known as quadratic equation. Every quadratic equation has two solutions or roots or zeros of the equation. The roots can be real or imaginary. We can identify by using the discriminant that the roots are real or imaginary. If b square minus 4ac is greater than 0, the roots are different and reals. If b square minus 4ac is equal to 0, the roots are same and real. If b square minus 4ac is less than 0, the roots are imaginary. Can we solve this equation? Yes, there are 2 or 3 most commonly used methods like factorization, completing the square method and the quadratic formula. But without using pen or paper, can we solve this equation by visualizing these shapes? Yes, we can. So put your pen down and do this with me. First, add both the shapes, square and rectangle. But the condition is new shape should be a square. No, we cannot add like this. This is not a square. To combine in a shape of a square, first divide the rectangle having area 4x into two parts of equal area and one side x. And add one part vertically with a square and another part horizontally with a square. Is this a square? Yes, this is a square, but this square is incomplete. To complete this square, we have to add a small square at the corner of side 2 having area 4. So, add this small square both the side to maintain the equivalence. Now we have a new square of side x plus 2. Yes or no? Now right hand side becomes 5 plus 4 which is equal to 9. Means our new square have the area which is equal to 9. If we write this algebraically, we can x plus 2 whole square is equal to 9. Or we can say x plus 2 is equal to plus or minus 3. And in case 1, if we take plus 3, x plus 2 is equal to plus 3, the answer is x is equal to 1. And in case 2, if we take x plus 2 is equal to minus 3, the answer is minus 5. These values are the solution of this equation or the roots or zeros of this equation. Now the question arises, why these values are called the zeros? Put these values in the equation. When we put 1 in the equation becomes 0. 1 square plus 4 into 1 minus 5 is equal to 0. So, when we put these values, the equation becomes zeros. That is why these values are known as zeros of the equation. Is this interesting? Here, first we complete the square and then find the solution. That is why this method is known as completing the square method. Is this interesting? Let me know in the comment box and like this video. Thank you.